thing we're going to look at are the integrals of the trig functions. So let's go ahead and just jump into some examples. And let's find each indefinite integral. All right, so I'm going to start with two easy ones that we should already know. Let's say first that we wanted to take the integral of the cosine of x dx. Okay, remember the indefinite integral is just the antiderivative. So the antiderivative of cosine would just be sine. Similarly, if we wanted to find the antiderivative of sine, that would just be negative cosine, since we know that the derivative of cosine is negative sine. Going backwards, we'd go from sine to negative cosine. Okay, so those are the two that we've already seen so far in the past. Now, what we haven't seen is the integral of tangent. Okay, now we don't know a function whose derivative is just tangent. So I'm going to be a little bit creative here, and I'm going to use a trig identity to split up that tangent as sine over cosine. Well, once we see that as a fraction, we can think about using the logarithmic integration that we were using in the previous two videos. So I'm going to use substitution and let u equal the denominator, cosine of x, which would make our du equal to negative sine of x dx. Okay, so then rewriting this, we have our 1 over cosine of x. I'm going to bring the sine out to the end with the dx. And then in order to get our du, we need a negative here, so we'll just balance it out with a negative out front. All right, so then this turns into negative integral of 1 over u du. And we of course know that the integral of 1 over u is the natural log of u. So this is negative natural log of u plus c. All right, now with that negative out front, we can use our log properties to bring that up as a power. So that would be the natural log of u to the negative 1. And remember, a negative 1 exponent just means 1 over u. Okay, but remember that our u was cosine. So this is the natural log of 1 over cosine. But 1 over cosine is just secant. Okay, so the integral of tangent of x dx is equal to the natural log of secant. Okay, let's do one more of these. Let's also find the integral of secant. Okay, so for this one, I'm going to show you a trick that I wouldn't expect you guys to just know to do. Okay, this takes some creative thinking here that is a little bit off the wall. So what we have to do on this one is we need to multiply by some factor of 1, meaning we need to multiply by a fraction with the same thing in the numerator and denominator. And what we're going to multiply by is secant x plus tangent x. Like I said, for this one, I wouldn't expect you to know that you needed to multiply by that. Okay, I'm just showing you how to go through this process. Okay, so then if we multiply that through, that becomes the integral of secant squared of x plus secant x tangent of x all over secant of x plus tangent of x. All right, now the advantage of doing this is once we have this fraction again, we can use substitution. So I'm going to let u equal the whole denominator, secant of x plus tangent of x. And then our du would be secant of x, tangent of x, plus secant squared of x, which conveniently enough is our numerator. All right, so rewriting this then, we have 1 over secant of x plus tangent of x, and then times our secant x, tangent x, plus secant squared of x dx, which of course is just the integral of 1 over u du. The integral of 1 over u, we know, is the natural log of u. And then just plugging our u back in, this becomes the natural log of secant of x plus tangent of x. Okay, so the integral of secant of x is equal to the natural log of secant of x plus tangent of x plus c. Okay, now before you get worried about having to memorize this for a test, let me show you this. Okay, so we just saw how to find the integral of tangent and how to find the integral of secant. I'm not going to go through and show you both of these, but I'm just going to give you the result. So we can also see here the integral of cotangent and the integral of cosecant. Okay, these will be provided to you on the test. Don't worry about memorizing these. You just need to know how to use them. Okay, so these will be given to you on a formula sheet for this next test. Okay, so now let's look at a couple examples of evaluating some definite integrals. Let's evaluate a definite integral. Okay, so let's say we have the integral from 0 to pi over 4 of the square root of 1 plus tangent squared of x dx. All right, so first of all, we're going to need to use some trig identities here. So remember your Pythagorean identities from your trig class. We know that 1 plus tangent squared of x is equal to secant squared of x. All right, so this turns into the integral from 0 to pi over 4 of the square root of secant squared of x. But of course, the square root of secant squared is just secant. Okay, now looking back up at our little cheat sheet up here, the integral of secant of x is equal to the natural log of secant plus tangent. So this is equal to the natural log of secant plus tangent. All right, and then we just need to plug in our limits. Okay, so starting with the pi over 4, we have the natural log of secant of pi over 4 plus tangent of pi over 4 minus the natural log of secant of 0 plus tangent of 0. Okay, so secant of pi over 4 would be square root of 2. Tangent of pi over 4 is 1. And then the secant of 0 is 1. Tangent of 0 is 0. So this becomes the natural log of the square root of 2 plus 1. The second term is just the natural log of 1, but the natural log of 1 is 0, so we can just drop that. And then if we plug this into a calculator, that's approximately 0.881. All right, guys, so that is it for our trig integration.